This video will introduce the division properties of exponents. We're going to talk about two different properties, then we're going to throw everything together and look at a couple examples that include all the properties that we've been working with exponents so far. So the first one is the quotient of powers property. And we all know what quotient means, right? Quotient means to divide. So with the quotient of powers property, to divide powers having the same base we subtract the exponents. And that makes sense because we know that when we were multiplying and we had the same base, we added the exponents. And since division is the opposite of multiplication, we're going to do the opposite of add, and that is subtract. So you're going to add the exponent. So let's look at what this looks like. First example. We have 6 to the 5th, and that is divided by 6 to the 4th. So we subtract the exponents. We have 6 to the 5th minus 4. 5 minus 4 is 1, so we have 6 to the first power, and that is equivalent to just 6. And the reason why this is, like when we talked about the multiplication, let's look at what this looks like in expanded form. If I have 6 to the 5th on top, 1, 2, 3, 4, 5, and I have 6 to the 4th on the bottom, 1, 2, 3, 4. If I cancel bottom top, right, 6 over 6 is 1. I could cancel that out. 6 over 6, 6 over 6, 6 over 6, and I'm left with that 1 left. So that's what it looks like in an expanded form, and that's what it allows us to just go ahead and subtract the exponents. Let's look at another example. I have negative 5 to the second over negative 5 to the second. So I'm going to go ahead and subtract my exponents. 2 minus 2 gives me negative 5 is my common base, and then 2 minus 2 is 0. And then we also know a property that anything, right, is raised to the 0 power is 1. So this is actually equivalent to 1. All right, a few more examples with this. It does get a little bit more complicated. I have 9 to the 4th times 9 squared over 9 to the 7th. So I'm first going to use the multiplication property, right? So if I have this base of 9, I can add my exponents. 9 to the 4th times 9 squared would give me 9 to the 6th. And that's going to be over if I have just 9 to the 7th on the bottom. So if I look, this is going to give me, let's say I subtract. So I have 9, and I do 6 over 7, or 6 minus 7, I'm sorry, that gives me a negative 1. I can't have a negative exponent, so I got to make, that's an exponent's not happy, so I have to make it happy and put it on the bottom, 1 over 9. That is the technical way to go about this. But you can also look, if you have 6 on the bottom and 7 on the top, the difference between 6 and 7 is 1, and since we started with more on the bottom, we're going to end with that extra 1 on the bottom. Okay, so that's how I look at this. I have a 6 up here, I have a 7 here. 7's more, so I'm going to end up with more on the bottom. How many more? 1. So that's where this 1 on that 1, 9 on the bottom comes from. But the technical way is because when you subtract 7 from 6, it's a negative 1. That's an unhappy exponent. We got to move it to the bottom and make it happy. All right, one more example with this topic. If I have 1 to y to the 5th times y to the 3rd, what do I equal? Well, we know, and we've talked about this before, when you have fractions, you can multiply straight across. So 1 times y to the 3rd is y to the 3rd. Y to the 5th times 1 is y to the 5th. Again, I'm going to look at this and say, okay, well, I started with more on the bottom, so I'm going to end up with more on the bottom. How many more? Well, what is the difference between 3 and 5? 2. You're going to end up with 2 more on the bottom. All right, so next topic, we're going to talk about one more thing, one more property, and then we're going to do some examples that involve all of these again. So for this next one, we have power of a quotient property. And we have actually done this already, but we have not officially taken notes and talked about it. So, power of a quotient. To find a power of a quotient, you have to find the power of the numerator and the power of the denominator and divide. Okay, so I know that's a little wordy, but let's take a look at a few examples and we'll see what this looks like. So my first example is going to be, I have 2/3, and that is the second power. So that's what it means by a power of a quotient. We have a quotient, right? 2 divided by 3, 2/3, and it's raised to a power. Well, we're going to, just like we did before when we had multiplication inside, we're going to distribute this 2 to both of those numbers inside. So now it changes to 2 squared over 3 squared. And again, 2 squared is 4, 3 squared is 9. So that reduces to 4/9. Look at a few more examples. I have -3 divided by y, and that's to the third power. Well, I'm going to go ahead and I need to this go to that -3, and it goes to this y also. So what that is equivalent to is -3 cubed. Make sure we have that parentheses around there. You're cubing that entire -3, and y cubed. Well, I can simplify that a little bit more. -3 cubed is -27, and I'm over y cubed. So that is my final answer. Got 2 more examples with this. So for example number 3, let's say that we had 7 over 4, and we're raising that to a -3. Okay, so now we know that we have an unhappy or an unhappy exponent, but we're going to do the same process. The first thing I'm going to do is I'm going to distribute this to both places. I use the term distributing even though I don't think that's technically called distributing. So I have 7 to the -3rd over 4 to the -3rd. Well, we know that we have some unhappy exponents here, so we have to switch. 7 to the -3rd, I have to make that -3 happy, so I'm going to move it to the bottom. And this 4 to the -3rd is on the bottom, but he's not happy, so I got to move him to the top. So now what am I left with? Well, I can simplify this. 4/3 is 64, and 7/3 is 343. So that would be your final answer when you simplify this. Okay, one more example here. Let's say we had 15 divided by 3, and we are squaring that. We can just automatically go ahead and simplify what is in my parentheses. Because 15 divided by 3 is a whole number, I can just go right ahead and change 15 divided by 3 into 5, and we're going to square that, and it would be 25. Go ahead and try it. See if you squared 15, would be 225, and you squared 3, that would be 9. 225 divided by 9 is still 25. So going the longer route would still produce the same number, but it's just easier to see kind of in the center. Okay, 15 divided by 3, that's 5. 5 squared is 25. Okay, so now we're going to look at all of the exponents together. All the exponent rules or properties together. So these are going to be a little bit more complicating, but they won't be too bad. Just a couple more minutes. So first one, I have 2x squared y divided by 3x times 9xy squared divided by y to the fourth. So again, we've talked about this time and time again. When you're multiplying fractions, you multiply straight across. So I'm going to go ahead and I'm going to multiply my constants or my coefficients. 2 times 9 is 18. I have an x squared here and an x to the first here. So when I'm multiplying, I add 2 plus 1 is x to the third. Again, I have an invisible 1 here and I have a 2 over here. So same base of y, I add y to the third. I'm going to go ahead and do the same thing on the bottom. 3 over here, I have a 1 here, so 3 times 1 is 3. I don't have any x's to multiply by, so I just have x, and then I have y to the fourth. So now I have to look at this each part. So I'm going to first look at this first part. I essentially have 18 divided by 3. Well, 18 divided by 3 is 6, so that simplifies to 6. Now I can look at my x's. I have 3 on the top and 1 on the bottom. 3 minus 1 would give me, I still have 2 on the top. Think about it. I have more to start with on the top. I'm going to end with more. What is the difference between 3 and 1? It's 2. And again, look at my y's. X to the third on the top, x to the fourth. Well, I see that I have more on the bottom, so I'm going to end up with more on the bottom. How many more? Well, 4 is 1 more than 3. So this is your simplified answer. It looks way nicer than this mess that we started with over here. Our answer is 6x squared divided by y. Of course, you don't need to have this 1 here in the answer. That doesn't need to be there. All right, 2 more examples. For number 2, I have 2x divided by y squared raised to the fourth. Okay, again, I have to make sure I take this exponent and it goes to everybody inside here, even in the denominator. So I'm going to be left with 2 to the fourth, x to the fourth, y squared raised to the fourth is y to the eighth. Now, I could simplify this even more. I know that 4 squared is 16, so 16 x to the fourth, y to the eighth. I don't have any negative exponents. I don't have any constants raised to an exponent, and I don't have any x and or y on the bottom and top to do any division with. All right, last one here. It's kind of a long one. Here we go. Two x y to the negative 2 y to the fourth over 3x to the negative 1 y. I'm going to raise this all to the negative 2 power, and I'm going to multiply it by 4x y divided by 2x to the negative 1 y to the negative 3. Okay, so I know this looks super intense, but we just have to follow the rules. The first thing we're always going to do when we see these parentheses is we're going to take these exponents on the outside and make sure they go to everybody on the inside. Every single one has to be raised to these exponents. So let's start. 2 to the negative 2, x to the negative 2. Y is already raised to a negative 2, so I have to multiply them. Negative 2 times negative 2 is 4. And then I have y to the fourth. 4 times negative 2 is y to the negative eighth. I'm just going ahead and multiplying everything out. I'm going to divide that by 3 to the negative 2. X, I have a negative 1 here, and I have to multiply it by a negative 2. Negative 1 times negative 2 is 2. And then y times negative 2 is y to the negative 2. All right, we're getting there. Let's do the same thing to the other side. 4 squared, x squared, y squared, over 2 squared. A negative 1 times 2 is x to the negative 2. and then y, a negative 3, and a negative, or a negative 3 and a positive 2 is y to the negative 6. Okay. So now what we have to do is we have to decide who's happy and who's not. And if they're not happy, we have to switch their places and make them happy. So I'm going to look at this first one. I'm going to actually move it a little bit. Uh-oh. There we go. Okay. So I'm going to start, and I'm going to move everything. This is our last problem, so just bear with me. 2 to the negative 2 is not happy, so it's going to the bottom. X to the negative 2, not happy, switching places. Y to the 4th is fine on the top. Y to the negative 8th, not happy. Moves to the bottom, becomes happy. All right, now let's look at the bottom. 3 to the negative 2 is not happy, so I'm going to put it at the top. I'm actually going to move it to the front. X squared is happy. Y to the negative 2 is happy. Or it's not happy, it needs to go to the top. All right, let's look at this one. Times. All right, here we go. My 4 squared is fine. My x squared is fine. My y squared is happy. My 2 squared on the bottom is happy. Oh, my x squared on the bottom is not happy. We have to move it to the top. My y to the negative 6 on the bottom is not happy. I have to move it to the top. Okay, a couple more steps. Let's see what we got. On the top, 3 squared, 3 times 3 is 9. I have y to the 4th and y squared at the top. I'm multiplying these together so I can add 4 plus 2 is 6, y to the 6th. On the bottom, 2 squared is 4. I have an x term here and an x term here, so I can turn that into x to the 4th, y to the 8th. And on the other side, I can turn this into 4 squared is 16. I have 2 x's. That becomes x to the 4th. I have 2 y's. That becomes y to the 8th divided by 2. Okay, well, I can start crossing things out. Remember, when you're working with this, you can simplify diagonally. So I can get rid of this x to the 4th, can cancel out this one. This y to the 8th will cancel out this one. This 4 will make this a 4. What am I left with? Oh, I can take this 2. Oh, 2 squared should be 4 on the bottom. I'm sorry. 4 on the bottom. This 4 can cancel out with this 4. Well, I've pretty much canceled everything out, and all I'm left with is 9y to the 6th power. So we went from this craziness up here all the way down to simplified as 9y to the 6th. All right, well, we will discuss this a little bit more in class.